In this video, we're going to be taking a look at dehydration. Now, the word hydration should be familiar to you from when I was discussing addition reaction. So we have an addition reaction called hydration, which is where you are adding a water molecule to an alkene, for example, some unsaturated organic compound. So if hydration is the addition of water, then dehydration is the elimination of water. And we are specifically going to be eliminating water from an alcohol, which makes sense because hydration was where we took an alkene, added water to it, and ended up with an alcohol. Now we are taking the alcohol and we are removing water from it. Now, reaction conditions that are very important for this reaction. We're going to have heat, so it's going to be performed in the presence of heat, and we are going to have an acid catalyst. Specifically, we can use sulfuric acid, learn this off by heart, or phosphoric acid as our catalyst. And this is a dehydrating catalyst, which means that the catalyst is there to assist in the removal of water. Our general equation would be an alcohol would be heated in the presence, so they haven't written down heat here, so it would be heated in the presence of some concentrated, remember the word concentrated, right? Concentrated means many particles, okay? We're going to have concentrated acid, okay, like sulfuric acid or phosphoric acid, and this is going to form an alkene and water. Okay, so let's look at an example of this type of reaction. We have ethanol. Okay, so we are starting here with ethanol, which is a type of alcohol. Our ethanol is going to be put in the presence, or we're going to add to our ethanol a catalyst like, so this is a mistake, it should be H2SO4, not 2, please. So a catalyst like sulfuric acid or phosphoric acid, you can choose, you don't need to write both, and heat. Normally we represent heat not as the word heat, but we use a triangle. You need to write both of these down. Then what is going to happen is our OH is going to detach. Our H is going to detach as well. These two are going to bond together to form water, and our carbons are going to have a double bond between them. Therefore, we are going to have ethene and water forming. Okay, very important here. Our acid catalyst, strong acid that is concentrated. We are going to have that, and we are going to form our ethene and water. So an example or a few more examples of dehydration reactions. Sometimes your molecule is not going to be symmetrical and you are going to have options once again. Since these are elimination reactions, we are going to be making use of Zaitsev's rule, which says we're going to remove the carbon atom from the we're going to remove the hydrogen atom from the carbon atom that has the least hydrogen atoms. We are only interested in the main, also called the major product. We're not interested in the minor product very much, but I'm still going to teach it to you just in case. So if we have a substance like butan-2-ol, butan-2 telling us our OH is on the second carbon, ol, it's an alcohol. From this substance, we are going to have to remove the OH and the hydrogen atom. So first we identify our OH. Now we need to decide, are we going to take a hydrogen atom from the left or are we going to take it from the carbon atom on the right? Zaitsev's rule says we are going to remove the hydrogen atom from the carbon on the right because it only has 2 hydrogen atoms attached to it, whereas the one on the left has 3 hydrogen atoms attached to it. So we're going to remove the hydrogen atom from the carbon that has the least hydrogen atoms in order to form our major product. So this will detach, that will detach, and they will bond, on this side, to form water. And where they used to be in between those two carbons, we will now have a double bond. So our major product is now but2-ene, and we have water. The minor product will form by not following Zaitsev's rule. So instead of taking away this hydrogen atom, we'll take away this one. And our minor product will then be but1-ene, because our double bond will be over there. But we'll still have water as our byproduct in this reaction. So this is a dehydration reaction. If you have any questions on it, you just let me know. We're at the end of this video.